Friends, how are you? I think you are fine. It is your friend. In this video, we will discuss about the concept of ionic compounds and concept of covalent compounds. So let us begin. So, what are ionic compounds and what are covalent compounds? To discuss their characteristics, their behavior, their formation, firstly, we are needed to know about the concept of electronegativity. So, what is electronegativity? You know that an atom is formed by protons, electrons, and neutrons. Protons and neutrons are present inside the nucleus of an atom while the electrons revolves around them. Proton carries positive charge, neutrons are neutral, while electron carries a negative charge. So, proton which are present inside the nucleus of an atom attracts the electrons, and therefore an atom will have a tendency to attract the electrons. This tendency of an atom to attract the shared pair of electrons towards itself in a covalent bond is known as its electronegativity. The smaller the size of an atom, more will be its electronegativity. Why? It is simple. Because if an atom is small, then the electron will be nearer to the nucleus and it will be attracted to it with a larger force. So it will have a higher value of electronegativity. You know that electronegativity of fluorine. Yes, fluorine is maximum in periodic table. And you know that the electronegativity of cesium is least in periodic table, which is an alkali metal. We can discuss why this is so. We'll discuss that in some other video, but in this video we will discuss about the formation of ionic bond and the formation of covalent bond. Before discussing the formation of ionic bond, we should have a clear concept. Clear concept of what? We should have a clear concept of octet rule and duplet rule. You know that we have so many elements in periodic table, and most of them have a tendency to acquire 8 electrons in their outermost shell. This is known as octet rule, and very few of them have a tendency to have 2 electrons in their outermost shell. So this is known as duplet rule. Duplet rule is generally is being accepted in case of hydrogen, in case of lithium, helium, etc. While generally we discuss about the octet rule. So when an ionic compound is formed, this is a very interesting question. Yes, this is a very interesting one. When it is formed. Okay, so let us see an example of sodium chloride. Sodium, the atomic number of sodium is 11. Atomic number of chlorine is 17. Sodium have 11 electrons and chlorine have 17 electrons. So the electronic configuration of sodium is 281, while that of chlorine is 287. It is clear that sodium can donate its 1 electron to chlorine, and if it donate its electron to chlorine, that sodium will have a configuration of 2,8 and it will form sodium ion Na positive, and when chlorine accept 1 electron from sodium, it will form chloride ion Cl negative, and we will have a compound named sodium chloride, which is commonly known as salt. So this is ionic compound. Really, it is a beautiful one. And we might have other ionic compounds as well, like potassium chloride, magnesium chloride, magnesium chloride, and much more, cesium chloride, etc. Okay, that's all about ionic compounds. Now we will discuss about the formation of covalent bonds. Okay, covalent bonds. Yeah, covalent bonds. Covalent bonds. Oh, covalent bond. For covalent bond, we should definitely consider the example of carbon. Carbon. Why carbon? Because the atomic number of carbon is 6. It have 4 electrons in its outermost shell. 4 electrons. Oh, 4 electrons. Oh, 4 electrons. What it will do about it? it cannot donate 4 electrons. This will not be an easy task for carbon. It cannot accept 4 electrons. It will also be a difficult task for carbon. So it wants to complete its octet, but neither it can donate nor it can accept. So what it will do? Oh, it will share 4 electrons, yes. And when sharing takes place, there will be a covalent bond. Yeah, and there we have covalent bond. Yes, covalent bond. Okay, so covalent bond are seen in case of carbon compounds and mostly in hydrocarbons. What are hydrocarbons? The compounds which formed by the combination of carbon and hydrogen. Oh, hydrogen. The atomic number of hydrogen 1, and it will share 1 electron of carbon, and so its duplet will be completed. How? Okay. Let's explain. Let us take an example of methane, CH4. In methane, we have 1 carbon atom and 4 hydrogen atoms. Yes, in methane we have 1 carbon atom and 4 hydrogen atoms. So the 4 electrons of carbon are shared by 4 atoms of hydrogen, and hence we have a covalent compound named methane. The duplet of all 4 atoms of hydrogen is being completed, and the octet of and the octet of carbon atoms is also being completed, and we have CH4. Yes, this will be a covalent compound. Interesting. Yes. Similarly, we can have CCl4, carbon tetrachloride. It will also be a covalent compound. So there we have covalent compounds and ionic compounds. Now the next part is their characteristics. You know how we will discuss the characteristics of them. Okay, it will be easy. It will be easy. Yes, easy. How it will be easy? Let us take an example, a general example. Suppose we have a metal which have very less value of electronegativity, and we have a non-metal which have a higher value of electronegativity. So a bond will be formed between them, and what kind of bond? It will be an ionic bond, because they have different values of electronegativities, and the electropositive element will donate its electrons to the electronegative atoms, and we will have ionic compounds. Yes, and you know, the attraction between a boy and a girl is always large, and the same thing is happened in case of ionic compounds. The attraction between positive cation and negative anions is always large. So the melting points of ionic compounds are so high, boiling points are also so high. In case of covalent compounds, the bond is formed between two non-metals which have similar electronegativities. And when a bond is formed between two elements which have similar electronegativities, ions are not formed. The bond which is formed between two boys, it will never be strong bond. So the force of attraction will not be so large, and when it will not be so large, melting and boiling points of covalent compounds are not so high. It will be comparatively low. Melting point will be comparatively low, and so will be the boiling points. So the melting and boiling points of ionic compounds are higher as compared to those of covalent compounds. Next, ionic compounds generally exist in solid state. Why? Because they have very high value of attraction, and higher the value of attraction, more will be the chances that a substance will exist in solid state. So ionic compounds generally exist in solid state. Oh yes, really. And if we take the case of covalent compounds, yes, they will exist in liquid, gaseous and solid state. Why? Because the force of attraction is not so high. So this is the reason, this is a simple reason that they exist in solid, liquid and gaseous state. Next is the solubility. Solubility in water. Water is a polar solvent, you know. Water have H positive ion and OH negative ion. So the H positive ion of water attracts the negative anion of an ionic compound, and the OH negative ion of water attracts the cation of ionic compounds, and this is the reason that ionic compounds are dissolved in water. And if we take the case of covalent compounds, they will never be dissolved in water because they don't have ions, and this is the reason that carbon tetrachloride is not dissolved in water. They are like not the same thing. Yes. So there we have ionic compounds, there we have covalent compounds. Examples of some general ionic compounds are sodium chloride, potassium chloride, calcium chloride, magnesium chloride, and potassium bromide and cesium chloride, etc. And all the hydrocarbons are covalent. I told you. And CCl4 is covalent, and CH4 is covalent, and methane, ethane, propane, butane, all are covalent. So that's all I want to say. So in this video we have discussed the covalent compounds, we have discussed the ionic compounds, we have discussed their properties, we have discussed octet rule, we have discussed duplet rule, we have discussed about the electronegativity, and that's all I want to say. So I hope that you like this video, and I hope that you will subscribe to our channel, and I will really appreciate the same if you could subscribe to our channel. And that's from me. Thank you for watching. Thanks a lot.